let's see. Let's put up our stuff. We got a longer lesson today. It's like 7 pages on Buzz. Well, six. That last page didn't ever have anything. But let's take a look at what we got. We go to the grade screen. Oh, I haven't turned something in from last week. My grade is down. Oh, I haven't. I still haven't turned in the Module 2 project. I did the repetition assignment from last week. This week we have iterative loops. 3.02 iterative loops. So let's go take a look at that. Here we go. I think this will pretty much take us the rest of the semester with Module 3 here. Python in entertainment. Have you ever spent hours trying and failing to get through a level of a video game? Yeah, I know I have. If so, you've been stuck in a loop, and the repetition won't end until you either beat that level or you just accept failure. I'm not going to make it. The entertainment industry has plenty of repetitive tasks that are made easier with programming, specifically by using loops. Check it out. Oh, just remind me, video games and loops. There was an Atari game that came out like in the late 80s called Pitfall. Pitfall. And it's a guy running through like the Amazon jungle. And it's very basic block graphics. They didn't have a lot of great graphic games back then. And you start and you can either go right or left, it doesn't matter. But you are running through the jungle, and like sometimes there's a pond that has an alligator in it. So you got to grab this vine and swing over the pond and let go at the precise moment to land on the other side of the pond. But you know, every screen there's different obstacles you got to get through. And there's probably 6 screens. They just keep repeating in a loop over and over and over and over. If you die 3 times, the game's over. But your goal was to try to make it all the way to the end. And the end was like a 60-minute timer. So for an hour, I think it was 60 minutes, something like that. Let's see, Pitfall. I'm going to look that up. Basically, for an hour, you'd be doing the exact same 6 screens over and over and over and over, trying not to die more than 3 times. Let's see. 1982, Atari video game Pitfall, which stars Pitfall Harry. The game involves collecting treasures in the jungle while avoiding obstacles like logs, alligators, and pits. So interesting. But it was just a one long loop, and it's like, I don't know, back then we would sit there and play the same. Oh, it says a 20-minute time limit. Okay, 20-minute time. We'd play the same level over and over and over and over and over. It's like it was designed to be an eternal loop, and it really was. But I just thought of that. I'll have to find a little video of that to share. Let's see. In film, character modeling, lighting patterns are certainly in loops. Special effects, repeated explosions. Using a lot of the same Python programming, specifically with loops. In gaming, character movements. Characters only move certain ways, behaviors. Game prototyping, iterative level design, like that Pitfall game. It was the same levels over and over and over. In music, you've got audio conversion, file transfer, sound design. Attractions have ride vehicle motion. It's just an endless loop of the same motions over and over again. Wait time estimation. They use Python for that. Ticketing and admissions. But putting it all together, you've learned about functions, if statements, loops, working with data. These are the tools used to create useful and functional computer programs. As a computer programmer, you will need to always be adding to your coding toolkit. That's why we'll be discussing a few more tools that will help your programs run more efficiently. Employability skills, keeping the focus on the end user. This is a big thing, and it's hard to get Programming 1 students thinking about this right now when they write their programs. If you had to cross a lake, would you rather take a rowboat or a paddle boat? I mean, both going to give you to your destination, but one's going to give you blisters and wear your arms out. The other one's going to give you a good leg workout. Your legs be exhausted. Which one you want to try? In programming, you need to focus both on accomplishing the task, getting across the lake, and ensuring a high value for the user. Make rowing as easy as popular. Great programmers always keep the end product in mind throughout the entire coding process. It means identifying and solving problems that will benefit the end user and have the integrity to follow through with these changes. So that's the thing I'm having in Programming 1. Students are just thinking about writing the program that just they can use. They wouldn't think about what if another user wanted to use your program, how can you make sure this works well for them? And that's the big thing. When they can get to that step, they get to be better programmers instead of just thinking, oh, well, I was just thinking what I wanted to do. A break statement. We're going to learn more about the break statement today. So you did it. You finally mustered up the courage to get on that fair ride. You get on, it starts spinning, and to your horror, it never stops. That would be horrible. Here's you're stuck in an infinite loop. Oh my gosh. Don't panic yet, though. Despite their bad rep, infinite loops are useful for continuing an action regardless of the user's input. For example, like a digital clock constantly keeping time. We don't want a break. We don't want that to be able to stop because then it's going to be wrong. Surveillance camera recording 24/7. We don't want criminals to be able to make that stop either. But sometimes, like when we're stuck on a carnival ride, we wish to terminate the current iteration or even the whole loop without checking the test expression. Is when we use the break statement. These are known as loop control statements. Controls your loop. So a break statement is used to end a loop that might turn into a never-ending story. It's like pressing an emergency stop button. There you go. When used inside a loop, the break statement exits the loop immediately. So any statements that are after that break statement inside that loop will not execute. It will immediately jump out of the loop to the next line of code past that. Break statements can be helpful if you need user input, but need to exit out if the user decides to quit. So here's a little sample when they did for us. And let's just copy this and put it in an idle window. Which, by the way, I found out our idle windows from like 2012, I think. 2012, yeah, I think it's a 2012 version of Python. So I thought it was pretty old. So we have a list of rides: the Ferris wheel, the swings, the bouncy house, and the roller coaster. So we have a list, and we set X equal to bounce house. So we're going to use a loop to print the items in the list, which is the rides, right? So for each in rides, there's our loop, for each in rides. So when X equal to the bounce house, we will meet the requirements for the break statement. If each, which each is their loop counter, equals X, if it equals bounce house. So the first time our loop's going to go for each, it's going to be equal to the first time in our list. All right, the 0 item, Ferris wheel. And then when it comes through again, it's going to change each to the second thing, which will be our item number 1 swings. When it equals X, it's going to exit our loop. Otherwise, it's going to keep printing. It's going to print through. Like the first time, it's going to be Ferris wheel, or that's not going to be equal to bounce house. So it's going to print that. So let's run it. It'll print Ferris wheel, it'll print swings, but then the next time it comes through the loop where each is now equal to bounce house, it finds, wait a minute, that's what I was looking for, break. So it just prints the first 2 rides, and then your stomach couldn't take any more, and the bounce house just seemed like too much, so you only rode the first 2. So although there are 4 items in the rides list, there's only 3 iterations because the third time through the loop, it hit the break statement. So first time through it printed, second time through it printed, third time through, oh, the if statement's true, I'm going to break. So the loop met the break statement criteria with bounce house and never continued the roller coaster. So here's a loop that finds the smallest number in a list. How many iterations will take place in this loop? Find main. Here's a list with numbers, 5 numbers. My numbers, 53, 38, 88, 1, and 129. And our loop is just really a print statement that says minimum. Print minimum of my numbers. So it's going to loop through looking for the smallest number. So when we run that, of course, it prints 1. So it made 4 iterations. The first time through, it found 53. That was not the minimum. 38 was not the minimum. 88. And the fourth time through, it says that. And we can also do maximum, and then we can get another iteration out of it because it should go all the way to get to 129. Yeah. Print max number. Looks for the largest number in our list. So check the answer. 4 iterations because it ran through the first 3, did not find what it's looking for. The fourth one did it. Now, how technically you say there's really only 4 iterations? Because in my mind, it has to run all 5 iterations to know what the smallest number is. How does it know the fifth one is larger than 1? But when it prints, it only prints the minimum one. It stops there. Continue statement. So if you got a break statement, we can also have a continue statement. Continue statements causes a loop to skip the rest and immediately retest its condition prior to reiterating. So here we go. This can be helpful if you want to avoid a lot of nested code. Like when using the continue statement, the code will be disrupted if it meets some condition, but then it'll go back and finish the loop. It will continue iterating through the loop. It's like pausing, skipping something, and then continuing on. If we need to exit the loop completely, the break statement, but the continue statement is a little bit different. Let's go back to the bounce house. All right, so we've got the same list. The Ferris wheel, swings, the bounce house, roller coaster. We've got X equal to bounce house again. And we're going to print for each in rides. So when X is equal to bounce house, the break statement is met, right? That's what it was. Flow of the control continues. So instead of putting a break, we're going to use a continue instead. It is going to equal bounce house just like before, but before we said, oh, if that happens, break, quit, get out of the loop, no more, you're done. This time when we run the program, it prints Ferris wheel, it prints swings. Oh, wait, it equals bounce house. That means, okay, I found bounce house, skip that, but continue on. I'm not going to ride that, but continue on. Ferris wheel, swings. It skipped bounce house and then went back through the loops to finish the loops until it got to the end of the list. So that's kind of cool. Instead of just totally quitting and omitting everything after that, you can finish your loops and pick up the rest of the data. Just skip this one. Skip whatever you're checking for. So when it goes bounce house, this is like skip, wait, don't do that one. Cancel this loop, go back, start a new loop with the next thing. So that's a little different. So that's a different type of thing than the break. So together, they're both very useful. So using break and continue. Look at the keywords carefully. Both alter the flow of a normal loop, which makes it difficult for others to understand where the condition ends in a program. So you just got to understand the difference. Both of them causes the loop to stop. Hey, wait a minute. But do I want to skip this and continue, or do I want to say, okay, I'm done, no more loop? Page 4, nested loops. So nesting information makes it organized and easier to understand. So let's take a look at a nested list, a list within a list. You might use a nested list in a program to organize music by genre or subgenre, the number of tracks. So define main. You've got a list called rock, and here's the list. It's in these brackets, right? That's the list. And everything inside the list, there's 3 items in the list, separated by commas. But each of those items are lists in and of itself. This list contains the word classic and the number 30. This one contains the word alt and 5 and contains grunge and 10. So inside this list of rock music you have it divided under. Here's a classic album that has 30 tracks on it. Here's an alternative album that has 5. Good. And then when you print it, let's see how that prints when we just print that list. I think it's just going to print the list, but yeah, it just prints literally the list. That's exactly, prints the list. So the concept of nesting can also be applied to other parts of the program, like loops. Loop inside of a loop. That's very useful, especially in the Turtle graphics stuff that we played with last year. You place any loop inside of another loop. Why would you want to do that? So to process data with nested loops, you can apply an action to all items within your array. Like you might want to add a track to each subgenre. Compare data. Nested loops can be used to process 2 separate lists or nested lists at the same time. Might come in handy if you want to find duplicates between playlists. Format data. If you want data to be easily readable, nested loops can be something for formatting. So let's look at this. We're going to take the same list we were using before, and we're going to do a nested loop, a loop within a loop. It says This is the outer loop. It contains the first iterating variable, or the genre, which would be the first thing on the list. This is the nested loop, and it contains the second iterating variable, tracks. So first it'll choose like classic, and then look for tracks inside that and print the number of tracks. Let's copy that. And look at it, it prints them on separate lines. So first it goes to this loop, and it goes to this loop, and when it prints first of all what loop I'm on here, and then print what's the tracks I'm on here. So it's actually a print within a print. First it'll print this loop, and then this loop. Classic 30, Alt 5, Grunge 10. So that's a little different way to do that. Shows the same thing there in the output. All right, let's look at their Python guided activity here. Printing a pyramid pattern with nested loops. So here's an outer loop to handle the number of rows for I in range 0 to 8. So we've got 8 loops from 0 to 7, basically. It stops when it gets to 8. And inside that, we're going to print for J in range 0 to I plus 1. So whatever loop number we're on out here in the outer loop, it's going to add 1 on the inner loop. And it's going to print an asterisk with a space after it. End equals nothing, so it won't have an end. It'll keep repeating it and then print a new line. Let's run it and see what it looks like. Look at there. So the first time through, this loop was equal to 0. So this went from 0 to 0 plus 1. It went from 0 to 1, and it printed this one time, an asterisk with a space. Didn't have an end there, but this made it print a new line. So that made it go to a new line. Came through the second time, this equals 1. So it goes through 0 to 2. There's 0, there's 1. It stops when it gets to 2. And it adds every time. One more asterisk space. One more asterisk space. Till it gets to the last loop where there's 8. So 2 more loops to print a pyramid, star pyramid pattern. That's kind of cool. So this is saying don't end the line. Just keep printing repeatedly on this line until you get to the end of this loop, and then it'll go to the next line. Printing number patterns. Say we have a starting number of 1. Now the outer loop handles numbers of rows for I in range 0 to 8. And again, we're resetting number to 1 because we're going to go through this loop multiple times. We want to keep resetting it back to 1. Inner loop to handle number of columns. So this is going 0 and I plus 1. So whatever loop number on here, we're adding 1. We're going to print what number it is, and then don't end the line. Keep going. Add 1 to the number every time through this loop, and then print. This goes to the next line when you finish this loop. When you finish this loop through printing all those, finish that line, go back and let's do another loop through. So what's this do? 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. So each time through there, I plus 1. So it's going one more loop, one more iteration through that loop than it did the time before. And it's printing whatever the number is this time. Remember, it starts at 1 every time because it resets it, but it keeps adding to it. Every time it goes through this loop down here, it adds another one to it. So when it comes through and prints that number, it's now 1 higher than it was the time before. Until it finishes that loop, then it goes back to I, another loop through until it gets all the way to 8. And just keeps printing from 1 to 8. Okay, print a pyramid pattern with nested loops. Oh, now it asks how many columns wide do you want the pyramid to be? And our loop will go 0 to that many times, however many times we enter. And we're going to do it with a hashtag in a space this time. I'm going to say 6. It is the base of my little right angle pyramid is 6 hashtags long. Now, if I said 3, Nice. What if I said 8? So let the user decide how wide, how many times it repeats the bottom of it. It just adds one every time with these nested loops. Nested loops. I like the little end thing too to be able to decide, hey, I know I'm going to come through here and print another one, put it in the same line. All right. Fun with patterns. Your turn. Read the code, try to predict the output, change the output, increasing the columns to a total of 7. So right now it starts n equals 5. Go through the loop 5 times then. This will be in the range of whatever loop number we're on, and we're going to print out asterisk with a space. And then after it's through with this loop, it's going to start another loop down here, and it's going to start it at 5 and go to 0 backwards, counting by -1s. We're stepping -1 each time. So we start at n equals 5, 5, 4, 3, 2, 1, and then stops when it gets to 0. And we're basically doing the same thing, printing whatever loop number we're on. So when we run this, 0, 1, 2, 3, 4, 5, 4, 3, 2, 1. So when it gets to the top, then this loop kicks in at the end and makes it go backwards. So it wants us to change that to 7. Since I used a variable that makes it real easy to do, we just change the n up here. Now it goes to 7 before it goes back to 1. That's pretty nifty. You can make some cool looking stuff there. Pretty cool looking things. All right, let's go to page 5. Random module with loops. The element of surprise comes in many forms. Hitting shuffle on a playlist, right? Editing sound for a jump scare in a film, or even randomizing the direction of a theme park ride. Oh, that'd be interesting. In Python, it takes the form of a random module, which can be imported and used to generate, I'm going to say, pseudo-random numbers and items. Computers are not real good at true random numbers. Pairing the random module with loops allows you to create all kinds of games, like guessing games, dice games, games of luck. But first, you got to know the basics. As you review each of the examples, put each of these in an idle window. So if you want Python to generate a random number, import the random module and use the rand range function. So let's take a look at just a random number. Define main. Let's put a little space and make it easier to read. Import the random. Number equals random dot rand range. So basically we're saying 0 to 50. Because remember, 51 is a stopping number. It should never choose 51. And when we run that, 22, 8, 6, 23, 12. Every time we hit run, we get a new number. 27, 13. I ran this earlier and I got 39 4 times in the first 15 times I ran it. It's like, it's not really as random as we'd like it to be. But all the numbers it's generating should be between 0 and 50. Many times we want to run it. Within a range, maybe we don't want to start down at 0. We can say, I want to generate numbers between 100 and 200. So 100 to 201, 145, 170. See, all these numbers should be between 100 and 200. There won't be anything 2 digits. There won't be anything 201 or higher. Or we can do just random items. See, it doesn't have to be numbers. That's a good thing to know as well. When we import the random here, we create a list. Space it out. We create a list that has rock, paper, scissors. So there's 3 items. And then we pick a random item using the random function. A range of 3. So either 0, 1, or 2. Either pick 0 item, 1 item, or 2 item, and then print from that list whichever item number you chose. I chose rock, paper, rock, scissors, 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 rock, scissors, scissors, rock. So it's just randomly choosing a number between 0, 1, or 2, and then printing that list number, 0, 1, or 2. So that could be pretty useful for a random type thing. especially combined with a list. Did you know random isn't just for fun and games? In fact, programmers use the random module in many different applications. For example, the random module can power features to appear randomly on a web page, like showing random ads or news articles. You can also use to assign random conditions in a controlled experiment, to compose music or digital artwork or random elements. You can use random for a lot of different reasons. Exceptions happen. So we're talking about getting some errors type things, right? No matter the program, where there's user input, there's going to be exceptions because somebody's going to enter something wrong. Thankfully, this is another area where loops come to the rescue. What are some exceptions you might run into in the entertainment industry, like gaming, verifying the correct response in a trivia game, music, ensuring that the proper audio file type is used, movies, making sure consistent edits are being made throughout the feature film, attractions, verifying if a ticket number is valid for that day's admission. So handling exceptions with loops. In Python, loops are often used to handle exceptions. Select each part of the code to see how it's done, and then we'll copy and paste this. So we have define main while true. So this is where the while loop begins. As long as this is true, keep running this loop. Try. Inside the while loop is this try clause, which says, okay, as long as this doesn't have any errors, let's do this. Be executed. So it says, okay, I equals input. Please enter an integer. So we said, okay, enter that. And then we're going to say, is that an integer? I equals integer I. We're going to say, hey, this is an integer. If there's an error where, wait a minute, that can't be an integer, it's going to break. We're going to get out of that loop and go down. Well, if it is an integer, it's when it's going to break and say, good, you just entered an integer. Because, okay, we tried it. It works. That's good. If this doesn't work, it's going to click down here to the except value error. If an exception occurred, wait a minute, that's not an integer. The loop will print line 8 and then go back and try again. Okay, there's a value error, not a valid integer, try again. So I'm going to go back up here and try again. Because when I tried it, wait, it didn't work. I got to go down here to the accept and let's try again. And we keep doing that until it gets something that's, hey, this is valid. I'm ready to break, get out of the loop. So let's copy, oops, I don't want to copy all that, just this. Now, of course, our version of Python won't show us the error message down here, but if we just enter an integer, 21, good job, you entered an integer. I entered a 21, it checked, yep, that works as an integer, so I will break and print line 9. But if I enter something that's not an integer, Bob, see, it loops right back to having me enter something again. Now, it printed a message down here. It's just our version of Python won't display it until we're done. Enter an integer, 75.68. Nope, I'm looping through again. Enter an integer, negative 0.4. Nope. How about 23? Yeah. There's the three things on there, Bob and a couple of decimal numbers. Then I got an integer. So that's using the try, value error, and the break to help get out of the loop. So the while just keeps running forever until someone actually enters something that works. Oh, that is an integer. I can break. Programmer Spotlight, Will Crowther. He's a game design pioneer. As an avid caver and a computer programmer, Will Crowther found a way to combine his hobbies. In 1976, he developed Colossal Cave Adventure. It's a text adventure game. You may have seen some of these. You can still find some around today. But yeah, the first adventure game was all reading, and you just typed your answers, and that's how you played the game. It was inspired by his trips to Mammoth Cave in Kentucky. Until Colossal Cave, a game's input typically came from directional commands. You just typed up, left, down, or right, down, right, up. That was how games worked. This was the first time that a game was directed to text commands. In the game, players gave a character text commands as they explored the cave and accumulated wealth. Colossal Cave inspired many more games to come. There's a bunch, including adventure games and popular role-playing games, RPGs, that are popular today. Like right here. To resume execution, type go. Other input will terminate the job. So they typed go. It says execution resumes after pause. Welcome to adventure. Would you like instructions? And they hit Y. Somewhere nearby is a colossal cave where others have found fortunes and treasure and gold. Though it's rumored to have, so it tells you the story, the whole setup of that. It says, I will be your eyes and hands. Direct me with commands of 1 or 2 words. Errors, suggestions, complaints to Crowther. So let's say that's the guy who designed it. If stuck, type help. So it does have a way, because sometimes in these games you didn't know what to type for. You're like, pick up hammer or something, and you didn't know. So you could type help, and it would tell you some commands you can use. You're standing at the edge of a road before a small brick building. Around you is a forest. A small stream flows out of the building and down the gully. Maybe you want to say open door to building or something. You just have to figure out what to type. And it wasn't really good at putting a menu. That's where the help, you needed the help, because it's like sometimes I have no idea what commands I can use. And help would tell you some commands you can use. So some of those got a little frustrating back in the early days because some people weren't very good at programming them as well as others. So that is the end of our lesson. It says follow the assignment template, because this week we have a program. So let's go to our Google Classroom. I do have the AI tool. If anyone wants to use it, you don't have to, but it is there. Let's look at the template on what our program is this week. Iterative loops. So now to understand how to nest loops, how to use loops to handle exceptions, how to use break and continue, random modules. We're going to put it all together. So here is step 1, decomposition. You want to create a text-based adventure game. In order for it to be a game, however, you got to figure out what players should do and how to track points earned and levels completed. Okay, so that's what decomposition. So pattern recognition, step 2. As you break down the problem, you decide you're going to have players choose whether to pick up an object or not. Oh, you're walking and you find a hammer. Do you pick it up? As the player collects objects, they collect points. Maybe the hammer's worth 10 points. Maybe this crown is worth 50 points or whatever. So here's where the fun and the assignment begins. Choose one of these options. You get 2 options. Could be an adventure game. Create a text-based adventure game of your own, where a player collects 3 items before they complete the level. Maybe you're trying to get the most amount of points, right? So I don't want to pick up the hammer. I want to pick up the crown. First, you should ask the player if they'd like to collect an item. Do you want to pick up the hammer? This says you get 1 point for each item collected. Well, that's no good. If they're all the same amount of points, that's all right. I don't care if you vary the points, your option. Finally, let them know their score and see if they want to play again. Or you can be creative, make your own scenario. It doesn't have to be picking up objects. Just come up with any scenario for the assignment, as long as you make it entertainment related, movies, music, sports, something else. Ensure people reading your code understand the scenario, but lots of comments in there, and follow the requirements. Here's what the requirements are. So when we write our pseudocode, it should be written in a series of steps, proper use of the random module, put a description of your text-based adventure game. Sure, got to have a description of it. Obtain user input in order to pick up objects or not pick up objects. Ask the user for at least 3. Make sure you use integer, float, and string, like if you're doing points. Include at least 1 nested loop. I should probably highlight that. With a break or continue statement. Demonstrate proper use of logical operators. Show proper order operations, any appropriate math functions if you need them. Just counting points, I guess, about all you'd have. Provide output. Clear, well organized. Use the string function when you need to. So here's an example of what someone else has done. Welcome to the mystery house. You enter a dark room and you can make out a small box from the floor. See, they print the description problem. Now, again, I know our version of Python isn't going to do this correctly. We won't be able to see the description before it asks inputs. But obviously it says something about, your small box. Do you want to pick up the box? You have picked up the box, it says. As you proceed further in the room, you see a small silver object. You have picked up the object. You notice a golden crown. Do you pick up the crown? You have picked up the object. So this is just what someone else says. At least 3 inputs. Here's some hints. I like this. Pseudocode for this program right here began with start. That That's where they define the main function, really. The next line of pseudocode said, welcome description. Well, this ended up being, you enter a dark room and you make out a small box on the floor. Welcome to the mystery house. That part there. Then the pseudocode said, ask if the player wants to collect an item. That was the eventual input, the box. When you're finished writing your pseudocode, ask yourself if a non-programmer could read it and understand what your program's going to do. So put your pseudocode there. Of course, name, date, description, use comments throughout your program, indent things properly, meaningful names, all the usuals. And then we have our 5 questions. So let's see. One nested loop with a break and continue statement. So it sounds like, thinking about with using a list with like these loops and stuff, nested loops. Sounds like if they're going to pick up 3 items, maybe you have a list of 10 items and you use the random function because it says demonstrate proper use of the random module. It would randomly pick which item they came across. You came across a stapler, or something. Seems like the list and the random function would work well with a loop. And do you pick up a yes or no? And you may have a try in there in case they don't type yes or no and they type what, or pick up the dog. There's not a dog, there's a stapler. So maybe that's a good use for your nested statement for break and continue. Did they type yes or no? I don't know. Different ideas. I'm just throwing things out there. You have lots of freedom, as usual, with these programs to kind of go the direction you want to go with it. You just have to demonstrate these different commands that we talked about, proper use of those type of things. But have some fun with it. You can create your own little written game. You may want to Google up some text-based games just to play with some and see how they work if you want to need some inspiration for that or something in there. All right, guys. Any questions on what we got this week? You got to play with the random and make your own little nested, game and stuff. So have some fun with that. This is an 8A Friday, so if you need help, I'll be here Wednesday and Friday. And otherwise, we will catch you guys later. Have a good day.